Hello, and welcome to The Science of Ageless Living. I'm your host, Dr. Ethan Hausman-Marquis, medical innovator, aesthetic pioneer, and lifelong student of the human body and its incredible potential. Broadcasting from the Catalyst Clinic with locations in London, New York, and Amsterdam, this podcast is your ultimate guide to unlocking the secrets of living not just longer, but better. I'm thrilled to have you here with us today. We'll embark on an enlightening journey into a topic that has captured the attention of researchers, health enthusiasts, and anyone interested in extending their lifespan. Caloric restriction and its profound effects on longevity. Caloric restriction, or CR, is the practice of reducing calorie intake without compromising essential nutrients. It's not just a diet trend, it's a fascinating area of study that has shown promising results in extending lifespan across various species. But what exactly happens in our bodies when we cut back on calories? Well, this is where it gets truly interesting. We'll delve into the intricate biochemical pathways that play a crucial role in this process, particularly focusing on insulin signaling and the mTOR pathway. Insulin signaling is vital for regulating metabolism and energy homeostasis, while the mTOR pathway is known for its role in cell growth and aging. Together, these pathways can influence how our bodies respond to caloric intake and, ultimately, our longevity. Throughout today's episode, we'll unpack the science behind these mechanisms, discuss recent research findings, and explore practical implications for our daily lives. Whether you're looking to optimize your health or simply curious about the science of aging, there's something in this episode for everyone. So, grab a cup of your favorite beverage, settle in, and let's get ready to explore the fascinating world of caloric restriction and how it might just hold the key to a longer, healthier life. Segment 1, Understanding Caloric Restriction. In this segment, we're going to take a closer look at caloric restriction, what it is, its historical background, and the exciting findings from both model organisms and human studies. So, what exactly is caloric restriction at its core? Caloric restriction is defined as the intentional reduction of calorie intake without causing malnutrition. This means that while you're eating fewer calories, you're still ensuring that your body receives all the essential nutrients it needs to function optimally. It's not just about eating less, it's about eating wisely. This approach has been a topic of research for several decades, and it's important to note that CR is not synonymous with starvation. Instead, it's a controlled dietary practice aimed at enhancing health and longevity. Now let's take a step back and look at the historical context of caloric restriction. Early studies in model organisms, such as yeast, worms, and mice, have been pivotal in our understanding of CR and its effects on lifespan. For instance, research conducted in the 1930s with rats revealed that those subjected to caloric restriction live significantly longer than their well-fed counterparts. Similar results have been observed in various species, including yeast and nematode worms. These organisms have a relatively short lifespan, making them ideal for studying the impacts of CR over a lifetime. In these early studies, researchers discovered that reducing calorie intake could lead to a host of beneficial effects, including improved metabolic health and delayed onset of age-related diseases. The findings sparked interest in whether these effects could be replicated in humans. Fast forward to more recent times, and we see a growing body of research focusing on humans. While the long-term effects of caloric restriction in humans are still being studied, several recent studies have shown promising results. For instance, a study published in the New England Journal of Medicine investigated the effects of caloric restriction in non-obese participants. The results indicated that participants who reduced their caloric intake by about 25% for 2 years experienced improved metabolic health markers, such as lower blood pressure, improved cholesterol levels, and enhanced insulin sensitivity. Additionally, researchers have found that caloric restriction can lead to reduced levels of biomarkers associated with aging, such as inflammation and oxidative stress. These findings are incredibly exciting because they suggest that caloric restriction may not only extend lifespan, but also promote a healthier life during those years. However, it's important to note that CR is not a one-size-fits-all approach. Individual responses to caloric restriction can vary widely, and ongoing research continues to explore the best ways to implement it safely and effectively in human diets. In summary, caloric restriction is a fascinating area of study that has roots in early research with model organisms and is now gaining traction in human health discussions. As we continue to uncover the science behind CR, it becomes increasingly clear that the way we approach our diets can have profound effects on our longevity and overall well-being. Stay tuned as we'll delve deeper into the biochemical pathways involved in caloric restriction and how they can influence our aging process in the next segment. Segment 2, Biochemical Pathways Involved in Longevity. In this segment, we're diving deeper into the biochemical pathways that are crucial for understanding longevity. We'll focus on 2 key pathways, the insulin signaling pathway and the mTOR pathway. Both of these pathways play significant roles in how our bodies respond to caloric intake and how they influence our lifespan. Let's start with the insulin signaling pathway. Insulin is a key hormone produced by the pancreas that regulates energy metabolism. When we eat, especially foods high in carbohydrates, our blood sugar levels rise. In response, the pancreas releases insulin, which facilitates the uptake of glucose into cells, allowing them to use it for energy or store it as glycogen. Insulin also promotes the storage of fat and the synthesis of proteins, making it an essential hormone for growth and energy storage. However, the relationship between insulin and longevity is quite intriguing. Research has shown that reduced caloric intake leads to lower insulin levels in the body. When we consume fewer calories, our insulin levels decrease, which in turn reduces insulin signaling. This reduction has been linked to increased lifespan in various organisms, including yeast, worms, and mice. But why does decreased insulin signaling correlate with longevity? One of the key reasons is that reduced insulin signaling can activate longevity pathways. When insulin signaling is diminished, it triggers a cascade of biochemical responses that promote cellular maintenance and repair processes. For instance, reduced insulin signaling can activate pathways such as the AMPK pathway and the sirtuin pathway, both of which are associated with increased lifespan and improved metabolic health. Moreover, insulin plays a significant role in promoting growth and fat storage. While this is essential for development, excessive insulin signaling can lead to insulin resistance, obesity, and a range of age-related diseases. By reducing caloric intake, we can lower insulin levels and shift the body's focus from growth to maintenance. This shift allows the body to redirect resources toward repairing damaged cells and tissues, which is crucial for longevity. Now let's transition to the mTOR pathway, which stands for mechanistic target of rapamycin. This pathway is a central regulator of cell growth and metabolism, responding to nutrient availability, growth factors, and cellular energy levels. mTOR plays a critical role in promoting protein synthesis and cell proliferation, making it essential for growth and development. However, the mTOR pathway is also intricately linked to aging. Research has shown that caloric restriction inhibits mTOR activity, which has profound implications for longevity. When caloric intake is reduced, mTOR signaling decreases, promoting a process known as autophagy. Autophagy is the body's way of cleaning out damaged cells and regenerating new ones, essentially allowing for cellular maintenance and repair. The inhibition of mTOR activity through caloric restriction not only promotes autophagy, but also reduces age-related decline. By limiting mTOR signaling, the body can enhance its stress resistance and improve metabolic health, which are both crucial for extending lifespan. Studies have indicated that mTOR inhibition can lead to a reduction in the incidence of age-related diseases, such as cancer, diabetes, and neurodegenerative disorders. In essence, the mTOR pathway serves as a critical link between nutrient availability and cellular health. By understanding how caloric restriction affects mTOR activity, we can gain insights into how dietary interventions might help us live longer, healthier lives. In summary, both the insulin signaling pathway and the mTOR pathway are vital for understanding the biochemical mechanisms behind longevity. Insulin regulates energy metabolism and promotes growth, while reduced insulin signaling can activate longevity pathways that enhance cellular maintenance. On the other hand, the mTOR pathway is a key regulator of cell growth and metabolism, and its inhibition through caloric restriction promotes autophagy and reduces age-related decline. Segment 3, the science of aging and caloric restriction. In this segment, we're going to explore the intricate relationship between caloric restriction and the science of aging, focusing on 3 significant factors: oxidative stress, inflammation, and hormesis. Let's begin with oxidative stress. As we age, our cells are continuously exposed to various stressors, leading to the production of reactive oxygen species, or ROS. These ROS are byproducts of normal metabolism and can cause damage to cellular components like DNA, proteins, and lipids. This damage accumulates over time and is a significant contributor to the aging process. Caloric restriction has been shown to reduce the production of ROS, effectively lowering oxidative stress levels in the body. When we reduce caloric intake, we not only decrease the overall metabolic rate, but also enhance the body's antioxidant defenses. This means that our cells are better equipped to combat oxidative damage, helping to maintain cellular health over time. Maintaining cellular health is crucial as it allows our bodies to function optimally and reduces the risk of developing age-related diseases. By mitigating oxidative stress through caloric restriction, we can potentially slow down the aging process and promote a healthier, longer life. Next, let's discuss inflammation and the concept of inflammaging. Inflammaging refers to the chronic, low-grade inflammation that often accompanies aging. This persistent inflammation can lead to various health issues, including heart disease, diabetes, and neurodegenerative conditions. Research has shown that caloric restriction can significantly lower inflammatory markers in the body. By reducing caloric intake, we can modulate the immune response and decrease the production of pro-inflammatory cytokines. This not only helps to alleviate chronic inflammation, but also improves overall immune function. A well-regulated immune system is essential for longevity. When our immune system functions optimally, we have a better chance of fighting off infections and reducing the risk of age-related diseases. Therefore, the anti-inflammatory effects of caloric restriction contribute not only to a longer lifespan, but also to an improved quality of life as we age. Now, let's introduce the concept of hormesis. Hormesis is the idea that mild stressors, such as those induced by caloric restriction, can trigger adaptive stress response pathways in the body. Essentially, when we experience mild stress, our cells respond by activating protective mechanisms that enhance resilience and promote longevity. Caloric restriction serves as a form of mild stress that encourages the body to adapt and strengthen its defenses. This adaptive response can include the activation of various pathways, such as the sirtuin and AMPK pathways, which are involved in cellular repair and metabolic regulation. By embracing mild stress through caloric restriction, we can potentially improve our body's ability to cope with more significant stressors, enhancing our overall resilience and contributing to a longer, healthier life. In summary, caloric restriction plays a vital role in addressing key factors involved in the science of aging. By reducing oxidative stress, lowering inflammation, and promoting hormesis, caloric restriction can help maintain cellular health and mitigate the effects of aging. Segment 4. Practical considerations and takeaways. In this segment, we're going to focus on the practical considerations for implementing caloric restriction into your lifestyle. We'll provide you with actionable tips, highlight the importance of a balanced diet, and encourage personalization based on individual health conditions. First, let's discuss some practical ways to incorporate caloric restriction safely and effectively into your daily routine. One popular approach is intermittent fasting. This method involves alternating periods of eating and fasting, which can help reduce overall caloric intake without requiring meticulous calorie counting. For example, you might follow a 16-8 schedule where you fast for 16 hours and eat during an 8-hour window. This approach can make it easier to manage hunger while still reaping the benefits of caloric restriction. Another simple strategy is to reduce portion sizes. Start by using smaller plates or bowls to help control the amount of food you serve yourself. Additionally, take your time while eating. This allows your body to signal when it's full and can prevent overeating. Being mindful of your eating habits can go a long way in helping you achieve your caloric restriction goals. While reducing caloric intake, it's crucial to maintain a nutrient-rich diet. It's not just about eating less, it's about choosing the right foods to ensure you're still getting all the essential nutrients your body needs. Focus on incorporating a variety of whole foods, such as fruits, vegetables, whole grains, lean proteins, and healthy fats. These foods are not only nutrient-dense, but also help keep you feeling satisfied. Avoid highly processed foods and those high in added sugars and unhealthy fats, as these can lead to nutritional deficiencies and negatively impact your health. Remember, the goal of caloric restriction is to promote health and longevity, so nourishing your body with the right nutrients is vital to achieving this. Finally, it's essential to recognize that caloric restriction is not a one-size-fits-all approach. Each person's body is unique, and what works for one individual may not be suitable for another. I encourage all listeners to consider their individual health conditions and circumstances before making significant dietary changes. If you have underlying health issues such as diabetes, heart conditions, or eating disorders, it's especially important to consult with a healthcare professional or a registered dietitian. They can provide personalized guidance and help you create a plan that aligns with your health goals while ensuring you remain safe and healthy. In conclusion, implementing caloric restriction can be a powerful tool for enhancing longevity and promoting overall health. By adopting practical strategies like intermittent fasting and portion control, maintaining a balanced diet, and personalizing your approach, you can successfully incorporate caloric restriction into your lifestyle. Segment 5. Conclusion. Thank you for joining me on today's deep dive into the fascinating world of caloric restriction and its effects on longevity. We've explored the remarkable science behind this practice, from its roots in early research with model organisms to its growing potential in human health. Along the way, we've unraveled the intricate biochemical pathways like insulin signaling and mTOR and how they influence our cellular processes to enhance lifespan and promote better health. So, What's the big takeaway here? Caloric restriction isn't just about eating less, it's about eating smarter. By reducing our caloric intake while maintaining essential nutrients, we're not just fueling our bodies, we're activating powerful biological mechanisms that focus on repair, resilience, and maintenance. We've seen how this shift can reduce oxidative stress, ease chronic inflammation, and even trigger adaptive stress responses, all of which are crucial for slowing down the aging process and improving both lifespan and health span, the quality of life during our later years. Of course, as we discussed, caloric restriction is not a one-size-fits-all solution. Individual responses can vary widely, and it's important to approach this practice with care. For some, intermittent fasting or portion control may be the right step. For others, it may involve small, sustainable adjustments to daily caloric intake. The key is to listen to your body, choose nutrient-dense foods, and always consult a healthcare professional before making significant dietary changes, especially if you have pre-existing health conditions. As we close, I want to emphasize that caloric restriction is just one piece of the longevity puzzle. It's a powerful tool, but it works best when combined with other healthy habits, regular exercise, stress management, quality sleep, and maintaining a strong sense of purpose. Together, these elements form the foundation for a longer, healthier, and more vibrant life. Thank you for tuning in to The Science of Ageless Living today. Whether you're here to optimize your health, satisfy your curiosity, or simply take the first steps toward a longer life, I hope you found this episode both illuminating and inspiring. Don't forget to subscribe, share this episode with someone who might find it helpful, and join us next time as we continue exploring the cutting-edge science of longevity and human potential. Until then, this is Dr. Ethan, signing off from the Catalyst Clinic. Here's to living not just longer, but better. Stay active, stay curious, stay healthy.